So we have 4 points, P, Q, R, and S are 4 points on the circumference of a circle shown below.
Oh, yeah.
This is 2017. Let's put 2017. I'm not sure if it's January or June. Right. So angles QRS, which is the angle that is indicated to be 58. Now they said using geometrical properties of a circle to give reasons for each step of your answers, determine the measure of SPQ. SPQ would be this angle underneath here. Now, especially children who were in class last week, what law can I apply here? What y'all seeing? Online too, eh? Y'all can answer. Anybody seen anything? I see in all 4 coordinates of this quadrilateral are on the circumference. Y'all seen that?
Yes.
So opposite angles in a cyclic quadrilateral add up to? Let me pull it up. 180. But let me pull it up because like, let's forget. Right, but we wouldn't find the angle at the center because it will be 2 workings in order to find that answer, which is this one here. Right, so I'm going to show you all the theorem. What's all that? Right, look at it. So, cyclic quadrilateral. A quadrilateral is any 4-sided shape, right? We know that. Now, opposite angles in a cyclic quadrilateral add up to 180 degrees. All 4 vertices must be on the circumference. You see how all 4 corners are on the circumference? Now, opposite Shania. Watch it there. These 2 angles are opposite. You see that? So, A plus B would be equal to 180. And then X plus Y will add up to be 180 degrees. Opposite angles in a cyclic quadrilateral add up to 180 degrees. Right? Right, so we going back here. Right, so you'll see that 58 and this angle would add up to be 180 degrees. So how would I find the missing angle? SPQ would be equal to what? Anybody? What is my working? Online. Anyone can answer. Excellent. 180 degrees minus 58, right? Because we want to get the unknown angle there in the cyclic quadrilateral. So what it will be? 180 minus 58? 122, right? So, right. So SPQ is equal to 122 degrees and you must give reasons. So your reason here will be opposite angles in a cyclic quadrilateral add up to 180 degrees. Shania, come here now. Come on. I think nobody else. Is this Nisia and Keegan coming? Is there 2 more people coming? Right, so you're heading up. This is number 10A in 2017. I think it's January, right? I think it's January 2017. So don't draw the figure. You just put in 10A part 1, put the answer, and put the reason. These reasons especially I want you all to memorize. And pause. Right, scrolling down. OQS, right? So they want O to Q to S. They want this angle. We found here to be 122 degrees, right? Anybody have any ideas to this angle here? Anybody? Ting. Right. So I just going back to it because it didn't come out in the recording, right? So this angle at the center here is twice the angle at the circumference, right? That's the law there. We have 2 radii here, 1, 2. So that means these 2 lines are equal. This triangle here would be an isosceles triangle. base angles in an isosceles triangle are equal. So let me start by putting what SOQ is. SOQ 116 angle at, please write down these reasons. Angle at the center is twice the angle at the circumference. Right? Angle at the center is twice the angle at the circumference. I ain't see nobody camera on online. All you know is a better interaction when I could see you all, right? I need to be able to see you all.
Afternoon.
So you're putting your cameras, please. Hi, Makeda. Right. Everybody good here? Write it down, eh? Write it down. I want to especially write these laws over and over. So especially for the people who weren't here last week, I want to show you all what the theorem looks like. Where is that theorem? Look at it. Angle at the center, right? So this is the circumference here. Angle at the center is twice the angle at the circumference. So if you have the angle at the center here, and then you have another angle being formed of these 2 points, and it touches the circumference, this angle is angle, we call it angle at the circumference, right? Angle at the center is twice the angle at the circumference. Now, if you have it shaped like this, which is actually what is going on here, right? So the angle behind here would be twice this angle. Cool? So that is another angle at the center is twice the angle at the circumference, right? Then if you have the same 2 lines here, 2x here, even if the angle is like pulled to the right up in this corner here, angle at the center is twice the angle at the circumference, right? That is the law. What you'll need to do, especially those who weren't here last week, I sent all of this in a group. Go ahead and write it down. Writing it down will help it to solidify in your brain, right? So we're going back here. Right, so we have here, and we said base angles of an isosceles triangle are equal. So what is it working to find these base angles here? Anybody? So this is OQS we find it now, right? OQS, Excellent. Excellent. OQS would be equal to 180 minus 116 all over 2 will give us what the answer is. What is the answer there? Anybody work it out? 32. 32 degrees. What I mean? It's like how you know everything. Yeah. I tell him, I say, because he don't add maths. So, hey, really tell him what I was saying. I want to start add maths class, right? I ain't want to come here again. So you good. Can do it with the brain. Right, 32. What's the reason we use that? Base angles in angles in an isosceles. Kyle coming online here. Like I gotta move back this class to Friday, boy.
What?
I mean to Sunday, sorry. You know, I was considering doing what I think about Saturday. Saturday has finished 3:30. So if I reach here 4:30, 5:30, 6:30, God, I'm gonna be late, buddy. Forget that. Forget that. I was going to try to pull it on Saturday, but no, forget that. And then physically, I just can't handle 3 classes in one day, boy. I just my brain just started glitch. Now we meet on Friday. Is that so? How much more weeks we have? About 5 more weeks? Yeah, boy. All this small talk is gigs, boy. All any mind to put in an isosceles triangle are equal.
It's also necessary to put the angles in triangle all at 180.
Nah, I don't need to put that. We don't put the base. So the diagram below, not drawn to scale, shows a circle with center 0. So you'll see the center O, right? The points A, B, C, and M are on the circumference. So A, B, C, and M are on the circumference. A straight line CN, this is CN here, is a tangent to the circle at the point C and is perpendicular to BN. So you see it forms 90 degrees here, right? So before we even go further, let's analyze some things now. What laws you all seen here before we even go further? Online, you all can answer to it. What laws we seen here? Avely, you seen any laws here that I seen a cyclic quadrilateral. I seen an angle in a semicircle. Very good. So watch it. Let me deal with cyclic first. So if I highlight A, B, M, and C, right? 4 vertices of a quadrilateral. You know that quadrilateral, right? 4-sided figure, right? Yeah. So we have 1, 2, 3, 4. So this angle and this angle opposite here add up to how much degrees? We just did this one like this, 180. This angle here and this angle up here add up to 180. Cyclic quadrilateral, right? So I reason that. Was just showing you all something, right? So somebody said they see angle in a semicircle is 90 degrees. Once you have a diameter, which is AB, and you have a triangle being formed of that diameter, this angle on top here would be 90 degrees, right? So angle, in a semicircle is 90 degrees. What else we see? Alternate what? Right, I see an angle between a tangent and a chord is equal to the angle in the alternate segment. So you have to focus on the triangle here, right, guys? Okay, everybody good there? Right, so let me see what CXC accent. I don't even know what CXC accent. I was just exploring the question, right? So I reason all this. Let's see what CXC actually wants, all right? Hey, smoking on. Right, let go. Determine. Yeah, you want to go outside and meet him? Yeah, you're calling Rich. All right. Determine, given a reason for answer A, B, C. So I'm going to highlight where A, B, C is. A to B to C. Let me hear you. We want here. What we just identified. Here's 90 degrees. Excellent. The reason for that will be angle in a semicircle is 90 degrees. And then what can we now use in order to find this unknown angle here? The 3 angles in a triangle add up to 180. So you have to give reasons for every step, right? So we have to first put A, C, B, right? So ACB is equal to 90 degrees and we must put the reason, right? Angle in a semi-circle is 90 degrees. Everybody good there? First thing, then ABC, you've seen it? So I find Shana looking confused. Watch it there, Shana. Hold on, let me show Shana the actual theorem from last day. Right, look at it. Angle in a semicircle. You see, once you have this diameter here, you see the diameter? A diameter is a line that goes through the center of the circle, right? Any triangle you form of that diameter is 90 degrees. You see that? 1. Look how form our next one here. 2. Look how form our next one here. 3. Right? In Shan, you see this, Mahabir?
Yes, sir.
Right. So any triangle, any angle that is formed of a diameter is a 90-degree angle, right? Any triangle we form. Cool? Shania? Some people weren't here last week too. Me and you now coming in this class too, right? So we're going back here. So we're going to find this angle here, which is ABC. So therefore, ABC is equal to 180 minus 90 plus what? 58. Is it 58? Yeah, 58. Yeah. 58. Right? So what would ABC be? 32, right? 32 degrees. And we must put our reason, right? Angles in a triangle add up to? I didn't know how much times I was seeing these things over and over last week, eh? Right? Or should I go and brainwash yourself for that video that I sent in the group? angles in a triangle add up to 180 degrees, right? Avery, you good there?
Yes, sir.
All right. So we roll in here. Kyle, where the camera?
Absolutely. Welcome to football. Shanti, I forget
We
it.
go up and see. So the next part is to find CMB. Come on, Ola. We had to start to see these things. You know, we did enough questions. C to the M to the B. Come on, that's food. What are we using for that? Huh? Oh, you get the thing. Right. What was the law? What's the law?
Opposite angles in a cyclic quadrilateral are 180 degrees.
Opposite angles in a cyclic quadrilateral add up to 180 degrees, right? For those who not seen the cyclic quadrilateral, look at here. Boom, that's one, right? Bang, that's two.
That's the same 2018.
Yeah, same one, yeah. 3 and 4, right? So the opposite angles will add up to 180 degrees, right? Okay, guys. Oh, I could undo this way. Undo. Right. So there we go. Scrolling down. So remember, this is 58, right? So CMB is equal to 180 minus 58, which will be 122 degrees. And my reason would be opposite. Yeah, opposite angles in a cyclic quadrilateral add up to 180 degrees. That reason is the most important thing here, guys. Please write down your reason. So this is part 2. Take a pause. Right, so we're trying to find angle NCM. You know what we could do? Simple, easy. And they said BN is a straight line because they said point C, right, is perpendicular to BN, which is a straight line, right? BN is a straight line. So if he has 122 and we could find here, yeah? So CMN would be equal to what? Let's write down what CMN is. CMN would be equal to 180 minus 122,000. So that'll be 58 degrees. Angles at a point. Angles at a point on a straight line add up to, lucky now I'm Tristan, add up to 180 degrees, right? Angles at a point on a straight line add up to 180 degrees. And then we could flow into NCM. NCM will simply be 180 minus, I believe it at 90 degrees, and there's 58. And we again, 132, I'm sorry, 32.
Yeah.
Right, 32 degrees, and I put 32 squared, yes. 32 degrees, and the reason here would be angles in a triangle add up to 180, proper thing. Add let me this. Right. The diagram below shows a circle where AC is the diameter, right? AC, boom, right? So if AC is the diameter, right? And we know some things we know. What we know about this angle up here? You all seen that?
Yes.
Angle in a semicircle is 90 degrees, but on this side also 90 degrees, right? You'll see me two triangles coming off the diameter there. Those two triangles are right angle triangles, right? That's the things I noticed as we read it. So B, yeah, I see the cyclic. Look, these two things, right?
Two opposite segments.
Yeah, right. So I finish it out. B and D are 2 points on the circle. 2 points, or B and D are two other points on the circle, B and D, right? So that's B and D would be these 2 points, right? And DCE, D to C to E is a straight line, right? Straight line. Then they say angle CAB is 28 degrees and angle D to B to C is 46, right? Let me see what CSEC wants to know. Now, they say calculate the value of each of the following angles, show detailed workings when necessary, and give reasons. Well, a reason to support your answer. So, DBA, let's work. D to B to A, food. What DBA is? Everybody seen that? This is, let me see what year this is. This is 2019. So, this is May. This is May 2019. Right, so if we want to find this angle here and we know the whole thing is 90 degrees, we simply do 90 minus 46. Cool? So let's work. So DBA, now the first thing we actually have to put we have to put that ABC is equal to 90 degrees. What will be the reason for this, guys? Come on, I hear them reasons. Angle in a semi is excellent. That's the first law to get ABC. And therefore, the angle we are looking for, which is DBA, would be equal to the 90 minus the 46.
43.
40, how much? 44. And we don't have to put no reason for this. We don't put the reason above. Right? Okay? This is the reason we use to calculate this. So let me unpause this. Right. So we want to find DAC, right? So we go in here, back to the, the circle terms. Watch the butterfly, Shana? Watch it. This is the butterfly. Angles in the same segment are equal. So if you have a chord which splits a circle into two, well, no, I understand a chord splits a circle into two segments, right? So angle X and Y are equal. You see the butterfly there? Oh, you show a butterfly. Because they telling me last week that's not a butterfly. I know when I was in primary school, you draw a butterfly so, right? And you put like a little head here, boom, and you put a little eye.
That's an eye?
Yeah. And a little mouth. You know.
What?
Something so. Right?
No, you are not special primary school.
That is the butterfly, right? So guys, this is the theorem behind what we're looking at on the next slide. Now this butterfly don't have to be like how you see how this one evenly proportioned. It could be big and small, right? But that's the two angles in the same segment are equal. So we're going back to the worksheet. Right. So let me highlight the butterfly. All right. So watch how I'm tracking it here. Marker. So we're going boom, bang, bang, bang. That's the butterfly. So this angle on top here, which is 46, would be equal to this angle on top here. Everybody agrees?
Yes.
Right. Let's write. So we're simply going to put angle DAC is equal to 46, sorry. So angle DAC is equal to 46 degrees. And the reason will be angles. So you all write same speed with me. So we're going to wait. Angles in the same segment are excellent. equal. Angles in the same segment are equal. Ooh, gigabytes running. Right, so BCE going up. B to C to E. We want to say this is not an angle between a tangent and a chord because this line is not a tangent, right? But let me erase up here. What we get here to be? What here was? 46, right? Right. We had this whole thing. Excellent. So we could find here. Right. Very good. So much here is here will be 46 plus 28, right? And then this angle and this angle, I should have put in a different color. Hold on. This angle and this angle here. You see this angle, right? And this angle here add up to how much degrees? 180. And then you can now proceed to say, that's why they told you that DCE is a straight line. So you can now proceed to say that the angle, well, angles at a point on a straight line add up to 180. So let's start by writing what DAB is first, right? So DAB is 46 plus 28, right? Let's start by writing that. So DAB is equal to 46 plus today is right? Right, 28 is equal to how much? 74 degrees. There's no reason for that. We just add two angles together, right?
Yeah.
Now the next angle on the opposite side was what, boy? What's the name for that angle? DCB. DCBA. I really like circle geometry, you know. DCB is one of my favorite topics. DCB is equal to 180 minus 74, which will be 106 degrees, right? This one have a reason. What's the reason here? Opposite angles in a add up to excellent. Opposite angles in a cyclic quad. Lateral add up to 180 degrees. Guys, today's the last day we spend on this, and next week we go to bearings. And I think I just want to spend about one class on bearings because I want to do matrices and vectors before this vacation done. If I do extra classes, we finish in matrices and vectors, and not starting back school and we incomplete matrices and vectors. So we'll probably do some online classes or something that's to make it up to make sure we finish it.
Like for one thing,
Nah, I don't be leaving our class, my brother. You know that. BCE, MBC is just 180 minus 106. And the reason would be angles at a point on a straight line add up to perfect. So what this is? 180 minus 106 is what? 78? No, 74. Right? Angles. Come, Shana, there we go. There you go, Shana. Angles at a point. Shana, you see from now, sister, until next year, try not to miss our class. Because there's real information you're missing. That goes to everybody. Try not to miss no class right now. Please. Angles at a point on a straight line add up to 180 degrees. Yes, angles in our semicircle is 90 degrees. I see two 90-degree angles. Oh, let's see that parallel line too. to a pair of parallel lines. So that means that we have alternate angles. I'm seeing a cyclic quadrilateral. Opposite angles in a cyclic quadrilateral add up to 180 degrees. Shana, you seen any of them things we seen? Right, they see the parallel. Watch. They see the diameter in the middle, sister?
Yeah.
Right. So you see them two triangles form of that diameter? 90 degrees. Boom, bam. 90, 90.
Yeah.
Cyclic quadrilateral, you see that? Go on. It's looking like a diamond, but that's nothing. We can't take that for wood. We go with what we know. Right? 90, 90. What is all this thing? Now let's say, right? Right. Where tangent, right? Where tangent, the tangent is A to B, where tangent and a radius meet, a 90-degree angle is formed also. So here's 90. Here's 90. Here's 90. All this we could see from just the theorems that we know. Everybody good there? Or if there's 90, obviously on this side is 92, right? So I'm going to erase all this and then we're going to see what CSEC stated. You must always read these things above here, guys. Because sometimes there's showing little information here that you might miss. So in the diagram below, E, C, G, and F, E, C, G, and F are points on the circumference of the circle, just indicating that E, C, G, F is a cyclic quadrilateral, right? EG is the diameter, boom, bang, right? The tangent A, EB at the base there, right, is parallel to the line CD, perfect. Angle ACE is 68, which is here, and then angle EFD is 106, thank you. Determine the value of each of the following angles, show detailed workings when necessary, give reasons to your answer. So we started with ECD, EC to D, that's this piece here. This is not 90, and is that 90? But I see now a pair of parallel lines and I see now transversal. Yeah. Pair of parallel lines, boom, bang, and a transversal. Right? So that means this angle here, if this angle is 68, what this angle up here would be? 68. And what are they called? Nobody remember that by online. Mia, you know that? Well, somebody say, oh, alternate angles. Right? So if here is 68, here is 68, boom. And the reason will be alternate angles are equal. Right? So let me work. Did I give that last day? I think I gave that in the just right, guys. I think I just gave it somewhere. I think we look at them thing. Look them here, brothers and sisters. A is equal to Z. So look at it right here. A is equal to Z. Alternate angles are equal. I just give all everything, you know, because I care. So let me go. Right? So just the only thing that might throw you off here is that in the original drawing, you know, like the line comes straight out here now. The parallel line, it could throw you off, but that's not the same thing, right, guys? Right, so let's start it right. Move this ink here. All right, so we go in. Oh, look at that, write it on my meanwhile, you know, 68 degrees and simply alternate angles are equal. Right? Am I going too fast?
No, minus.
Right.
No, minus.
This is number is 20, 21, and is number 9.
Yeah.
Yeah, number 9A, part 1. Alternate angles are equal. All this thing, and I even press play. Right, so we want to find CEG. CEG? Right, CEG. So where a tangent and a radius meet, a 90-degree angle is formed. Yeah, put rocket on silent there. So if he has 90 minus 68 would give us the piece here. Everybody agrees? So we need to first put that AEO is equal to 90 degrees and put the reason. So AEO is equal to 90 degrees and the reason would be where, so please write these things, I mean these things to stick in all your head, where a tangent, where or when? Yeah, Mrs. Bernard Christian, where a tangent and radius meet, a 90-degree angle is formed. Right? That's the first law. And then CEG would simply be equal to 90 minus, who can remember what the angle was? 68. And what you get when you minus it? 22 degrees. So there's no law there because we already put the law up here, right? Right, let me see what's going on with C to G to F, right? That's this angle here. Right, what are you thinking, buddy? And we just found here? Here was what? 22? Right. Could we find, yeah, but even if we find this, we wouldn't have it. What are you all thinking? You're trying to find up here. Yeah, what are you thinking, right?
We know angle C is the right angle.
Okay, what are you thinking? I'm thinking if he has 106, right? We could find this whole angle here. Because if he has 106, this whole thing is 106. Because they are alternate angles. This angle on this side here is equal to this whole angle here. So we can't find this piece here, right? So let's find C, E, F. So I'm going to write only working for that. C to E to F, right?
So that would be AEF.
Huh?
AEF, that way angle.
A, E, F. No, I'm gonna find this, right? I'm gonna find this angle here. So watch it.
Oh.
C, oh yeah, I need to put that. AEF is equal to 106. I need to put that first. You're very correct. Right? So AEF is equal to 106 degrees. Alternate angles, right? Angles are equal, right, Shana? Are equal. Come on, let's go. Are equal. Right? Alternate angles are equal. Then we want to find this angle here now. No, it probably have a next way to find this, but this is what I see here. Right? So watch it. This angle here, which is CEF, would be 106 minus 68. Right? 106 minus 68. Okay? So C to E to F, CEF is equal to 106 minus 68. What again there? 106 minus 68.
Minus 68 would be
106 minus 68. Anybody? 38. You sure? Yeah. 38 degrees, right? Now we could proceed to find our CGF is equal to 180 minus 38, which will give me what? What is CGF?
that would give you 42. 142, sorry.
142.
142? That's not enough. Fix this. CGF. Right. 142 degrees. And the reason here would be opposite angles. Right? Opposite angles in a cyclic. Shania, a cyclic. Right? Come right. When you write it would internalize. Cyclic. Quadrilateral add up to 180 degrees. Right? Opposite angles in a cyclic quadrilateral add up to 180 degrees, right? Okay? Yeah, pause for real. Right, so this is June 2025, right? So the points L, M, and P lie on the circumference of the circle whose center is O. The line N to P is a tangent. So this is actually a tangent. So it stops here, but it can actually keep going on and on here. Okay? It can't go on and on, right? But it stopped there. So as they said, the line PL, P to L is a diameter, and ONP is 24. O to N to P. That's all the information they give us. Calculate the value of each of the following angles, show detailed working when necessary, and give a reason to support your answer. P to O to N, which is this angle up here. That is very easy. Let me see if you can figure out that. This is the paper that the students did this year. If you can figure out this, get yourself a pat on the back.
P to N.
Yeah, P to O to N. Let me hear. Right? Where a tangent and a radius meet, our kind of angle is formed. So here's 90 and here's 24. The three angles of a triangle add up to how much marks this was, boy? This is a real kind of food question for 2 marks. So the first thing we had to put that NOP is equal to 90 degrees. What's the law again? Internalize these laws, eh? What's the law? To show here is 90. Where or when, anything you want to put, when a tangent and radius meet, A is formed. Excellent. Olive, sing that for me tonight now. I feel like I'm going to make up a song with that, you know. Where a tangent and...
Oh, please, don't do that.
All right, Liam. Well, this is number 9. 9, part B. Huh? I don't hear you. When? Yeah, where. I think where would be more precise. Hold on here. Where a tangent, should I write in where tangent and a radius meet a 90-degree angle is formed, right? Where a tangent and a radius meet, a 90-degree angle is formed. Then to proceed to find what the question asks, right, which is PON would be equal to 180 minus 90 plus 24, which will give me what?
66.
66. Very good, Marber. Right, 66 degrees. And what's the reason for this? Angles in A add up to
180.
right, angles in a triangle add up to 180 degrees. Right? Huh? Right, let's see what they're asking for next, right? We're going down. PLM. P to L to M. What kind of food thing is this, boy? PLM, right? They want this up here. Right? So what we know, let me start putting some things. What we got here to be? What we found here to be? 66 we just find here to be, right? Right? So if you find here to be 66,
Side of that would be
this you're seeing this is two ways you could take this, right? Right? You could actually find here, right? And then this will be isosceles triangle because this is our radius and this is our radius. You see that? Base angles in an isosceles triangle are equal. Or you could have said this is our radius, this is our radius. So like these two would have been equal. Then you would have still had to implement that 90-degree angle is here. And then you could proceed to find here. Or you could say the angle between a tangent and a chord is equal to the angle in the alternate segment. You see how much different routes you can take?
I think the first method is the easiest.
I will take the first one I stated. I ain't like the others. Right, Shana? So what is the law that could help us find LOM, which is here? What's the law for LOM or the reason?
Those are the points.
Angles at a point on a straight line add up to 180 degrees, right? So that will allow us to find LOM. So let's write. Scrolling down. All right, so LOM is equal to 180 minus what was my 66? Yeah, and what again? What is this? 114?
Yeah.
Right? 114 degrees. Angles on a straight line. Angles at a point. Angles at a point on a straight line add up to 180 degrees. Everybody good there? Angles at a point on a straight line add up to 180 degrees. And from there, we can proceed to find PLM. So PLM will simply be 180 minus the 114 all over 2. Somebody give me the answer there. Well, that'll be 33. See, that's 33 degrees. And this will be base angles of an isosceles triangle are equal. Base angles of an isosceles triangle are equal. Everybody good there? Scrolling up for y'all to see. I'm going to scroll up for y'all to see and then I'll come back for y'all to write. Okay? For those who didn't see it, we found here first, which was 114, sorry.
Right.
Here was 114, right? LOM was 114, right?
PON 66, then?
Yeah, PON was 66.
And then
And then this will be 114. And then we proceeded to find, well, the base angles of this isosceles triangle are equal. But that will actually give us LOM, right? So LOM will simply be 180 minus this 114. Whatever you get to divide by 2, and it will give you each one of these angles, right? That's how I got is it 33? Right. So those who need to write, go ahead and write. And then thank you. Right. Let me hear what you do.
So triangle LPM and all the angles are at 180. I use angle L, which we just found, and angle M. And I found P, and since angle P is 90 degrees, I found the in angle P. And then just found M.
All right, I take another different road though. Right? So I have 66 here. Everybody see now, we have that, right? This is our radius up to here. Okay? What's your Shana? This is our radius up to here. This is another radius up to here, from here to here. So these two lines are equal. Base angles in an isosceles triangle add up to? No, not add up to. Are equal. Are equal, right? So if we know here 66, we can find what these two angles will add up to. We divide it by 2. We'll get this bad boy here, right? Once we get this bad boy, 180 minus this bad boy will give us PMN. right? So we're going to proceed to find OMP first, right? So watch what OMP would be equal to. Scrolling down, right? OMP is what we're going to find first. So OMP, Tristan, OMP would be equal to 180 minus 66 divided by 2. How are you getting here? 37? 57, right? Everybody get here? 57 degrees, right? And this will be base angles in an isosceles triangle are equal. Everybody good here? So we found OMP. Scrolling up. I'll come back down. I'll just scrolling up to show you all, and I will come back down. Right? Right. So we're going up. Going up here. We found this angle here to be 57, right? So if he has 57 degrees, what this angle will be? What's he working? 180 minus
57.
Right, because these two angles are angles at a point on a straight line add up to right. So we go back down. Right, so PMN is equal to 180 minus 57, which will be 123 degrees, and the reason will be angles at a point, right, Shana? A point on a straight line add up to 180 degrees. Cool? Pause that. Right. So we can actually find C from this question because angle at the center is twice the angle at the circumference. B is actually equal to 62 because angles in the same segment are equal. 18 is actually equal to E also because, wait. No. That is not a butterfly. You know why it's not a butterfly? Because this point and this point in what I thought was a butterfly there are not touching the circumference. These 2 points must be on the circumference. So you see for this butterfly here, guys, online? Watch. If I erase this and I erase this, right? Right. You see how all 4 points in this here, well, for this butterfly, boom, bang, 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 all 4 points are on the circumference, right? So this, watch it there, this is actually equal to this here. You all seen that? 18 is actually equal to this. Because watch, if I draw the butterfly here. Yeah. Watch it there. I'm going to draw it out. Boom, bang, bang, bang. Ooh. Real off there, boy. That's right. Let me back. All right, let me take my time. This marker can get smaller, boy. Yeah, let me go to 10 now. It's smaller so I can get it, right? All right, there you go. So you're going down, right? Then you're going up. Everybody good there so far? Then you're going down, then you're coming down here. Right, you all see the butterfly there? So these two angles are equal, these two angles on the top here are equal, and this angle here is equal to this angle here, right? But let me see what CXC is asking us for. Right? Let's see what Mr. CXT is asking us for. Yeah, I seen some theorems there, boy. Right. State a theorem that justifies the value of each of the following angles, right? So let me scroll along and see. So I see B is equal to 62. What's the theorem that justifies that? Angles. So let's start it right. This is 2024 June Number 9 what by? Number 9, A, 1, then A again. Angles in the same segment are equal. Right? So that's how we know B is equal to 62. Preston, you good there?
Yes, sir.
Mahabir,
Yes, sir.
Shepherd,
Yes, sir.
Lou,
Yes, sir.
Makeda, this one there's no who not by the laptop.
Yes, sir. Right here.
All right, very good. Karim, Miriam, no Miriam. Pushet, no Pushet, no Miriam. Rishi,
Yes, sir.
all right. There we go. Come now, Lishla. I could have paused this. Miriam. Right. C would be 124. Why is C 124? Why? What's the reason for that? What's the justification? C is 124. What's the reason for here being 124?
Well, I understand the theorem.
Oh, look at right here now. If he has x, he has 2x.
Yep.
Angle at the center is twice the angle at the circumference. Look, you see that? Let me draw them because I feel some all in see this. Watch it. I'm going to draw it. Boom. Bang. And then you have this angle at the circumference here. You see that there? Angle at the center is twice the angle at the circumference. Okay? So let me work. Write it down. That's the answer for part B. Angle at the center. Come on, right? Just done. Is twice the angle. Hey, what's that? At the look how I spell circumference. Circumference. Right? Angle at the center is twice the angle at the circumference. That's the thing. Right. So next we have angle OVW is 90 degrees. What's the reason for that?
The radius with the tangent. Also.
Excellent. Where a radius meets a tangent, a 90-degree angle is formed. Let's write. Only we need to write these things over and over, and otherwise it won't stick. Write it over. There we go. Angle, or no, not angle. Where? Keep writing. Come, Shana. Let's go. Where a tangent and radius meet, a 90-degree angle is formed. Yeah. Right, Oli, last one. Last 40 minutes. There you go. Final push it. This is it for circle geometry. We're not coming back to this topic, eh? Shania and Tristan. There you go. Tristan, there you go. Right. Find the values of A, D, and E. Show all workings where appropriate, right? So we go now. A, D, and E because we found everything else. So what do you all want to start with? Could we start with A? Angle between a tangent and a chord is equal to the angle in the... Check that law. Angle between a tangent, this is the tangent, right? And this is the chord. Angle between a tangent and a chord is equal to the angle in the... Right, so we're looking at the triangle up here. So the alternate segment would be this angle on top here, which is 62, right? For those who was not here last week, let me just pull it up here. Scrolling down, right, look at it. Angle between a tangent and a chord is equal to the angle in the opposite segment, right? So if you have this angle here, Shania, is equal to the angle on the other side, right? So going back here, it's the next way around. So if you have A here, it will be equal to 62. So let's write that in, please, guys. So let me get a pen. Right. So A is equal to 62 degrees, and the reason would be angle between... They didn't, but they put show all workings are appropriate, so I just put my reason. Because all we have is a reason here. Angle between a tangent and the chord, Tristan, is equal to the angle in the alternate. Come on, right. We all right. In the alternate segment. Right on that, then we'll go and see what's going on with D. D, scrolling up, right? Right, so we want to see where D is. Any ideas to D? Let me raise this here. Come on, let's start to watch the D by the meanwhile. Yeah, once we have here, exactly, very good. You all see this is an isosceles triangle. These two lines are equal. So base angles, which is this angle and that angle, base angles of an isosceles triangle are, let's go. So we know C is 124. We know that. We privy to that information, right, Tristan? All right. So this is equal to 180 minus what was 124? All over 2. Find it one time. What are you getting there, bro?
28.
56 is the final answer now. 28, yeah. Very good. I hear my very belt it out. Very good, guys. 28, right? Well, we get workings here, so I ain't going to put no reason. Because they didn't ask the reasons here. But you all know base angles in an isosceles triangle are equal. Right? Ready for E? Ooh, that's all I'm answering. This lady. Hi. Yeah. Hello? Here, no. Right. E, right? That's this angle here. What are you seeing for the angle, right? Any ideas to this angle here? E. I seen here 62, right? We know this whole angle here. What this whole angle here is? What this whole angle is?
That would be 28 plus 18.
28 plus or 26.
28.
Yes.
28 plus 18, right? And here would be 28 also, right?
Yes.
So if here is 62, here is, well, whatever 28 plus 18 is, 46.
Yeah.
And we need to find this, right? You could find the entire angle, which is XZV. And then when you find that entire angle, you minus 28 from it and you get a little piece here. You all seen that? So let me work. I want to write this a little better. Yeah, let me hear your way. You see our next way?
No angle Z, the entire thing there is 90 degrees because angle 77.
Right.
Is 90.
Right. And we know here's 18.
There's 18.
Yeah. That's an easier way. Let me go that route. You all see how much ways it have to do these things, right? That is an easier route. All right? But you had a... All right, so watch it. Watch what he's saying, right? So that's another route to do it. So this is angle in our semicircle is 90 degrees, and we know here was 18 because remember we have a bow tie here, or a butterfly. Okay, so if here's 18, here's 18, which is angle Y, ZX is 18. So 90 minus 28 plus 18 would give me this missing angle here. So let me put that as our working, right? So E is equal to 90 minus 28 plus 18, which will give me what? 80? 80 degrees, right? No?
No.
Nah, that can't be 80.
44.
44?
Yeah.
44 degrees, right? And the reason would be, well, I put in a reason, right? The main reason we use here is angle in a semicircle, just done. Semicircle U is 90 degrees. And you know what? We also used angles in the same segment are equal. Angles in the same segment are equal. Right? Yeah, like pause, yes. On pause. LM, so LMNR are points on the circumference of a circle with center O. PQ is a tangent. Okay, we've seen PQ is a tangent to the circle at R. Well, they meet at R. Then they say angle PRL is 48. And then RON is 156, right? Okay, let me see what the question is asking us. So I find this question actually looking like it's going to be real easy. Find the value of each of the following angles given reasons for each of your answers. Show all workings where appropriate. R. So we start with R. Food. What R is equal to? That's food. Come on. What R is?
So 48 degrees.
48? No.
56 divided by 2, 78 degrees.
Thank you very much, Kia. Small. All right. 156. Them online people cracking, boy. 156 divided by 2. And what's the reason here? 78 degrees. What's the reason? I think you said earlier. The angle at the center is twice the angle at the circumference. That was one of the first things you say you see in. Which one you're watching? Here on this side?
On outside. The capital R.
That's not coming nowhere.
She was looking at point R, capital R, to the right of the circle.
Oh. Okay. So you seen something with angle at the center is angle at the circumference?
No,
Oh, no. This R. Because it's common R. Yeah, it's common R. Right? So that is this. This they're looking for, right? So let me put my reason because they asked the reasons, right? Angle at center is twice the angle at the circumference. Right? Angle at the center is twice the angle at the circumference, right? Everybody good there? Right, let me see what they're asking us for next. Or you all need to write. Everybody good there? Tristan, you write this? E. Let me go with E. We're going to E. I talked about that earlier. What is E? E is easy. tangent, angle between the tangent and the chord is equal to the angle in the alternate segment, right? Look at here, my children. So watch it there and then watch it what I'm going to show you, all right? Watch it here. Where is it? Look at here. Angle between a tangent and a chord is equal to the angle in the alternate segment. So basically, you have a triangle being formed of the chord. The angle between the tangent and that chord is equal to the angle on the opposite side or in the alternate segment, right? So watch it here now. Let me give it some perspective with the marker. Watch. This is the tangent, right? And watch the triangle. Boom, bang, wee, miss. All right, you see it? So it's basically, right. So the angle between the tangent, the angle between the tangent and the chord is equal to the angle in the alternate segment, right? So let's write that down. So, right. So how much I want you to get? 78? Right. So simple. Let me scroll along. Right. E is simply equal to 78 degrees straight up angle between the tangent and chord is equal to the angle in the alternate segment. Right, proper thing. Angle E. Right. Scrolling up. Let me highlight this angle E. I found here, right? I found E. E is 78. Let me highlight this. Come on, we had a think, you know. We had a think. I see, and I can find this whole angle here.
And then angle, opposite angles in a cyclic.
Boom. Boom. Right? Oh, you see it? If I find this angle here, cyclic quadrilateral, 1, 2, 3, 4, all 4 points are on the circumference, right? So once I find this angle here, these two angles will add up to be 180 degrees. That was excellent, right? So there we go. We're going to find first angle LRN. So LRN is equal to 180 minus 78 plus what, by? Anybody remember? I'll scroll up, by. 78 plus 48. Right. So what would that be here? 78 plus 48.
HRM?
L.
Is 111 plus 60, 126.
54.
Oh, yeah.
54, right? Reasons angle at a point on a straight line add up to 180 degrees, right?
So, I can't finish it now, of course.
Yeah, that's how we go finish. Yeah, true. Huh? Wait, we ain't done here. Angles at a point. Then we need to find A. A is equal to 180 minus 54, which will be what? 180 minus 54 is what? 126.
Yes, sir.
Right? This will be opposite angles in a cyclic quadrilateral. Ooh. in a cyclic quadrilateral add up to 180 degrees. Right, so the question is asking us, explain given a reason why angle HJM is equal to 30 degrees. What reason are there for that? HJM, right? Where H to J to M. So they're talking about here. Why would this angle here, my children, be 30 degrees? What's the reason? Alternate angles. Excellent. Alternate angles. You see the parallel lines here? 1, 2. Yeah, your transversal going from one parallel line to the next. This angle and this angle are equal and they are alternate angles, right? So let me just write alternate angles are equal. So this is number 9, 2022, right? Number 9, A part 1. So alternate angles are equal. Everybody good here?
Yes.
Okay. Write it down. And then I guess in MJK, I could probably start to write that one time. Right? Let me just see what is stating, right? MJK. MJK. That's this angle here. What's the reason for that, Tristan? Why that's 90 here?
Where's that the MJK?
Yeah. Why this is 90? Angle in a semicircle is 90 degrees, right? All I don't know what I'm thinking of, Tristan. Angles, sorry. In a, so write down these two things as your answer. Semicircle is 90 degrees, right? Angle in a semicircle, not angles, angle. Right, everybody good here?
Yes. Wait.
Hey, pause. Determine the value of each of the following angles. Show detailed workings where necessary. MLG. Let's go. M to L to G. That's this bad boy they asked us for. Anybody have any ideas there? M to L to G. I see now isosceles, but right, but we need to add the angle on top here. What are you thinking? We have here all kind of things we were seeing earlier.
Just go down.
Is there any way to find this angle? We know here's 38, right? No, here's 90. Oh, watch it.
What?
If here's 38, here's 90, and we can find here. And three angles of a triangle add up to. And then these two is butterfly. Let me do the butterfly. Right? Angles in the same segment are. So let's proceed to find MKJ first, right? So MKJ is what we're going to find first. So MKJ is equal to 180 minus 90 plus what? What was 38? Sure? 38. So we can work on this.
180 minus 128.
Yeah, 180 minus 128. 52?
Yeah, that's
52 degrees. All right? Everybody good here? Reason would be angles in a triangle add up to 180 degrees. All right? And now with that information, we could proceed to find MLG, which is equal to same 52 degrees, and that reason would be angles in the same segment are in the same segment are equal. All right, excellent. Okay, everybody good here? Pause, because I know some other item. Right, so we want to find LG key, right? So I reason this because we found this. We have here, where? What here was? That's not how go wrong, eh? What here was? What we do got here to be? 52, right? And here's 52 also, right? Right? So what we want LJK? LJK, which is this here. What are you thinking? Here's 52. That means this whole thing is 52. Huh? And I can find here? And once I find here, you'll see that here and here are angles in the same segment. You'll see that? So let's find LMK. So LMK is what we're going to find first, right? So LMK is equal to 52 minus 38, I think. Right. Well, again, 14 degrees, right? And then, therefore, LJK would be equal to the same 14. Now, what's the reason? Angle in the same segment in the same segment, Shania. Same segment are equal, right? So that question done. Let me see if we could do JHM one time, because that's the last question we're doing for today. JHM. JHM is up here. Whoa, that's easy. That's the easiest thing here. No, the isosceles angle is here. What are you seeing? Anybody seen anything here? Come on, we're not leaving here until I don't tell you what to do for this one. Figure it out. We're trying to find, yeah.
Just H alone.
Yeah, MHG.
L is 52 and?
Yeah, L is 52. Yeah, you want to something there? M. We want to find M. No, they call it JHM. How do you find JHM? So, pause like we go be here for the rest of the evening, but. Huh? Kyle not here. Kyle join and leave, but it was here saying plenty noise in the background. All right. Just go through this part again. Opposite angles in a cyclic quadrilateral add up to 180 degrees, right? And that's it. What we getting here? We're getting 128. Yeah, 128 degrees. Opposite angles in a cyclic quadrilateral add up to 180 degrees, right? Party done.